310 polynomial long division. If we look at long division in general, like this example, 949 divided by 23, we know that we're going to look at that 949 and see how many times that 23 goes into it. When we do this, we start by looking at the 23 and seeing how many times does 23 go into 9. Well, it doesn't. So we move to the 4, 94. How many times does 23 go into 94? It goes in 4 times. When we do this, there we go. It goes in 4 times evenly. So the 4 times 23 is what we would do next. So 4 times 3 is 24, or 12. Carry the 1. 4 times 2 is 8, plus 1 is 9. We subtract, and we get 2. Bring down that 9. So 23 goes into 29 one time. From there, 1 times 23 is 23. Subtract the 2, and there's 6 left over. So we have 41 with a remainder of 6. If we were to do this fraction-wise, it would be 41 and 6 over 23, because the 23 is what we are dividing by. It is the same concept for when we divide polynomials. So we are going to start with the terms on the outside. We want to first make sure that everything on the inside, all of our exponents are represented. So if our highest exponent is x squared, we have an x, we have a constant. If not, we have to represent that with a 0x whatever that we're missing. So we're going to look at the 4x and the 8x squared and say to ourselves, what times 4x is going to give us 8x squared? Well, a 2x times 4x gives us 8x squared. Our whole idea is to get the same first term underneath the like term that it is. So from there, I'm going to multiply the 2x by 4x, which gives me the 8x squared, and the 2x by 1, that gives me a 2x. Then I'm going to subtract these two, which means I'm going to, hold on one second. I'm going to subtract these two, put it on the outside of the parentheses. When I subtract, it's the same thing as adding the opposites. So the 8x squares are going to cancel. The 6x minus 2x is 4x, and that 3 gets brought down. So from here, I'm going to say what times the 4x is 4x? It's a 1. So I'm going to multiply the 1 by the 4x and the 1 to get me 4x plus 1. I'm going to subtract these two. Remember, subtraction is the same thing as adding the opposites. The 4x's cancel, and the 3 minus 1 is 2. When I have a remainder with these, I'm going to have the 2x plus 1 as my solution. However, I have a remainder of 2, so that 2 is going to go over what I divided by, which is the 4x plus 1. If for some reason our remainder had a sign with it, it would stay with the numerator in that fraction that we make with the divisor as the denominator and the remainder as the numerator. If we look at example 1, we're dividing 34x minus 16 plus 15x squared divided by 5x minus 2. So that 5x minus 2 is going to go on the outside. That inside has to be put in standard form, so that 15x squared is going to go first. Then we have that 34x, and lastly the negative 16. All of our exponents are represented, so we're going to start with what times 5x is going to give us the 15x squared. Well, it's a 3x, so 3x times 5x is 15x squared, and 3x times negative 2 is negative 6x. I'm going to subtract these, or add the opposites. The 15x squared cancel out. The 34x plus 6x is 40x. And we bring down my next term, which is that negative 16. So now I have 5x times what is the 40x? Well, if I multiply the 5x by 8, that's going to give me 40x. And then I do the same thing with the negative 2 to give me a negative 16. I then add these, add the opposites, or subtract. The 40x's cancel, and so do the 16, so I have a remainder of 0. So my answer is just that 3x plus 8. So if I don't have a remainder, I don't have to put anything over that divisor. If I do, I have to put my remainder over my divisor. If we look at example 2, we have 2a cubed plus 5 divided by a minus 3. So the bottom is going to go on the outside. The a minus 3 goes on the outside. Look at the top. We have a 2a cubed, but we don't have an a squared, nor do we have an a. So when we write this, we're going to write the 2a cubed. To represent that a squared, we're going to have a plus 0 a squared, and then to represent that a, we're going to do a plus 0a, and then continue with that plus 5. So then start. A times what is 2a cubed? 2a squared. So multiply the 2a by a minus 3. That's going to give us 2a cubed minus 6a squared. I then subtract these two, or add the opposites. The 2a cubes cancel. 0a squared plus 6a squared is 6a squared. I drop down that 0a, and then I start all over again. The a times 6a squared, or sorry, the a times what is 6a squared? It's a positive 6a. So 6a times a minus 3 is going to give us 6a squared minus 18a. So then I'm going to subtract again, or add my opposites. The 6a squared would cancel. 0a plus 18a is going to give us 18a. I drop down my next term, which is that positive 5. Then I do a times what is 18a. A times 18 is 18a, so that 18 is going to go up top. And then I'm going to multiply the 18 times the a minus 3. So 18 times a is 18a, and 18 times 3 gives us 54. So we're going to plus 54. That's a minus 54. And then I'm going to subtract these. Now it's going to turn into addition. So I'm going to do 5 plus 54, which is 59. So my answer for this one is going to be the 2a squared plus 6a plus 18 plus 59 over. I'm going to redo all of this so that way we have a little bit more room. Maybe do it on this side. Yeah. So 2a squared plus 6a plus 18 plus 59 over, what do we divide by? A minus 3. For example 3, we have y squared minus 2y minus 35 divided by y minus 7. So that y minus 7 is going to go on the outside. The y squared minus 2y minus 35 will go on the inside. You realize that we have all of our exponents represented, so we can just write that polynomial underneath the division house. So I'm going to start off with y times what is y squared. That gives me a y. I'm going to multiply that by y minus 7. That gives me y squared minus 7y. I'm going to subtract these two, distribute that negative by adding the opposite, cancel out my y squared, then the negative 2y plus 7y is 5y. Bring down that negative 35. Y times what is 35? I'm sorry, y times what is 5y? It's going to be a 5. I'm going to multiply that 5 by y minus 7 to give me 5y minus 35. I'm going to subtract these, which is the same thing as adding the opposites. The 5y's cancel out, so do the 35, so I have a remainder of 0. My answer for this one is y plus 5. For example 4, we have 7 plus k squared minus 4k divided by k minus 5. So that k minus 5 is going to go on the outside. And then that 7 plus k squared minus 4k has to be put in standard form first. So that k squared minus 4k plus 7 is what's going to go on the inside. So k times what is k squared? K. Multiply the k by k minus 5. We're going to get k squared minus 5k. I'm subtracting these two, or adding the opposites. The k squareds cancel. 4k plus 5k gives me k. And then the 7 I'm going to drop down. So k times what is k? It's just a 1. I'm going to multiply and get k minus 5. Subtract or add the opposites. The k minus k cancels, and the 7 plus 5 is 12. So I have k plus 1 plus 12 over k minus 5. For 5, we have b cubed minus 1 over b plus 1. So we have b plus 1 is going to go on the outside. The b cubed is going to go on the inside, but I'm missing a b squared. So I'm going to put 0b squared, and I'm also missing a b, so I'm going to put plus 0b. minus 1. So b times what is b cubed? B squared, multiply, b squared plus 1b squared. I'm going to subtract or add the opposites. I'm going to be left with a negative b squared. Bring down that 0b. Now b times what is negative b squared? It's a negative b. So b times b plus 1, or negative b times b plus 1 is negative b squared minus b, or 1b. Subtract or add the opposites. I'm going to be left with just a 1b, or b. I'm going to drop down that negative 1. So I have b minus 1 now. So b times what is b? That's a positive 1. I'm going to rewrite that underneath and subtract or add the opposites and get negative 2 as my remainder. So my answer for this one is b squared minus b plus 1 plus negative 2 over b plus 1. So see if I did this correct, or I did. But the negative 2, that's our remainder. Since it has that negative on there, it's going to stay with that 2 in the numerator. If we look at example 6, we have v cubed plus v squared plus v plus 1 divided by v minus 2. That v minus 2 goes on the outside. The v cubed plus v squared plus v plus 1 goes on the inside. So v times what is v cubed? That's v squared. Multiply. We're going to get v squared minus 2v squared, or v cubed. Subtract or add the opposites. The v cubes cancel. V squared plus 2v squared is 3v squared. Bring down that next term. V times what is 3v squared? That's a positive 3v. So multiply the 3v by v minus 2. We get 3v squared minus 6v. I'm going to subtract or add the opposites. The 3v squared cancel. V plus 6v is 7v. I'm going to bring down that 1. And now I'm going to do v times what is 7v. It's a positive 7. So multiply the 7 by v minus 2. It's going to give us 7v minus 14. I'm going to subtract or add the opposites. The 7v's cancel. And I have 15 left over as my remainder. So my answer for this one is v squared plus 3v plus 7 plus 15 over v minus 2.